Michael Friesen was a materials engineering manager for ATK, a former aerospace and defense company, now part of Northrop Grumman. He is now semi-retired and takes on consulting cases. Last year, he was working in the UAE, and currently he is working with the FAA. When I asked Michael to describe the design process, he said it's lengthy, iterative, and challenging, and it often starts with a well-defined problem statement. The engineers develop prototypes, but sales and marketing teams often reject them, citing reasons like insufficient innovation or marketability. We have read many articles about the cyclical nature and various prototypes, but I had not put much thought into engineers having to think about the marketability of products. An example of a project that Michael gave me was a project he was working on with a door spring. The initial problem was a lack of strength. Solutions were limited by space and temperature sensitivity. They eventually went through 25 prototypes at $5,000 apiece. The project was initially estimated at 6 months, and the entire process took 9 months. His answer to me demonstrated the impact of constraints on the design process. I asked Michael, why is the engineering design process an important framework for engineers? He said that it defines a stable process for us to experiment. And he gave an example of a project with SpaceX. And he said that if something happens to him or his team, that the project might be pulled, that the information that they have been working with can be transferred to another company and that everything is documented. This is something that I had not previously considered before, the transfer of information from one company to another. When I asked Michael what is the fastest growing engineering field, he said it's environmental engineering. And the most important reason for that is because of the amount of chemical byproducts coming out of our households right now, which is amazing to me, and it shows how important it is to find innovative solutions to some of the most pressing challenges in our country today. He then went on to say another growing field is aerospace engineering, which is a field he is actually currently working in right now. He said a lack of diligence in testing can cost hundreds of lives. Everything in aerospace is thoroughly tested and presented to the FAA, which then requires further testing. Aircraft experience extreme temperature swings from negative 50 degrees Fahrenheit to 120 degrees Fahrenheit, requiring engineers to account for expansion and contraction of materials. A specific challenge is hydrogen grooming in the screws on aircraft doors. The heat treatment process while hardening the metal can also introduce hydrogen, making the metal brittle. A controlled heat treatment process is required to move the hydrogen without compromising the metal's toughness. This process is time-consuming and depends on the type of steel and specific heat treatment. When he gave me that answer, I thought, this is just a fascinating issue. Not that I fully understood it, but I thought it was fascinating, and I thought it's amazing how such a small thing like the presence of hydrogen in screws can have such a huge impact on safety. It makes you appreciate the level of detail that goes into aerospace engineering and how much is in our daily life that we don't even understand. How is failure part of the design process? Failure is integral and expected. When I was talking with Michael and I thought about his answer, I thought, this is an important, and it may be a bit advanced for my fourth graders, but I'm going to find a way to share the core message with them. Getting them to embrace failure as a learning opportunity is so important, and this provides a great example. I asked him, do you find that the engineering design process is adaptable to different types of engineering challenges? He said, yes, almost everyone uses the same discipline. You go in with the problem statement. You get your team together, you sit down and work out exactly what you want to do. You put together a couple of prototypes and you never do one prototype. That's ludicrous because if you only have one prototype, When you inevitably have to go back to the drawing board, you'll have nothing else to work with. So yeah, it works, and it works with almost everything. This part of our interview was probably one of my favorites. How does the engineering design process contribute to innovation and problem solving? He said the innovation comes more from the failure side. You have to do a lot of testing and experimentation. But that's part of the innovation process, doing the experimentation. Just because it doesn't work like you planned doesn't mean it's always a failure. If I was showing this video to my students, I'd pause the video here and ask two questions. First, do you agree with this statement? And second, can anyone share an example of something great they created unintentionally? His quote affirms every article we read for this class, discussion, and lesson we have in class. My interview with Michael Friesen confirmed the alignment between the concepts we are teaching and the daily work of practicing engineers.